So good afternoon. Today we are moving on to the topic solubility. So it is coming under the syllabus BP 302.1 under course outcome CO1. So what is course outcome? It is the statement a student get to know after learning a particular subject. So we are in physical pharmaceutics. Today we are learning the chapter solubility. So after learning the chapter, what are the things that we get to know? Okay, we'll understand the basic concepts of solubility. We can apply the solubility parameters and what are the factors that influences the solubility of drugs and the Raoult's law. By studying the Raoult's law, we get to know what are real solutions and ideal solutions and applying distribution law or the importance or significance of partition coefficient. Okay. Then Bloom's level. Bloom's level means it is to classify the questions based on thinking level and it mainly includes 6 types. Okay. Under this chapter, it only includes 5 types. That is remembering, also denoted by K1, understanding K2, applying K3, analyzing K4, evaluating K5. There is also one more category, creative, which includes K6. But under this chapter, we are not dealing with the creativity, things like that. So, only dealing with these 5 categories. Okay? So, solubility. I think you are familiar with this term, solubility, from your school level. Okay? So, what is solubility? In simple terms, the amount of solute when it is get to dissolve in a solvent, sometimes it may get solubilized, sometimes it may not get solubilized. But the amount of solute that is dissolved in a solvent, it is generally called solubility. We can look the definition. It is the ability of a solute to dissolve in a solvent to form a homogeneous solution. Okay. That is the amount of solute when it is dissolved in a solvent that forms a homogeneous solution. It is called as solubility. Okay. The component which is dissolved in a solvent is known as solute. And the component of medium in which the solute get dissolved, it is called as solvent. Okay. You are familiar with those terms, right? Solute and solvent. Next, when does a solute will get properly dissolved in a solvent? When does? You tell me. That is based on the principle like dissolves like. A polar solute will get dissolved in a polar solvent. Similarly, non-polar solute will get dissolved in a non-polar solvent. A solute will get in a solvent if both the solute and solvent are of similar chemical nature or both the solute or solvent possess the what obeys the principles of like dissolves like. Types of solution, 3 types: saturated, unsaturated and supersaturated. Saturated solution means what? You might have heard the term, something reached its saturated level, means what? Has reached its maximum level. That is, contains the maximum amount of solute that can dissolve in a solvent at a given temperature. That is, in that particular solvent, the concentration of solute has attained its maximum level. So, there is no more further space to get more solute to be added. That is called as saturated solution. Unsaturated solution means what? Contains less the solute than the solvent's maximum dissolving capacity at a given temperature. That means that particular solution, unsaturated, means the solvent has more space for further more solute or more solute to be added. Okay. Next, supersaturated solution. Supersaturated. Saturation means the solute concentration has reached its maximum amount. And unsaturated means what? The solute concentration has not reached its maximum amount in the solvent. So, there is furthermore space for furthermore solute that can be added. And what about supersaturated? Supersaturated means contains more the solute. Okay, that solvent has a particular capacity to hold certain concentration. If the concentration of solute is more than that, that particular solute will precipitate or crystallizes out. And that particular solution is known as supersaturated solution. So, are you clear about these terms? Saturated, unsaturated and supersaturated. Saturation means what? Or saturated solution means solution containing maximum limit or concentration of solute. And what about unsaturated? Contains a concentration of solute less than the maximum dissolving capacity of the solvent. And supersaturated, more the concentration of solute that normally contained in the saturated solution, that usually that solute will precipitate or crystallizes out. Okay. Solubility expression. Solubility can be expressed in two ways. Okay. Qualitatively and quantitatively. Okay. Qualitatively, you're doing qualitative analysis in labs. So what are you doing? Like for salt analysis, you're observing the color reactions and you're telling something. Similarly here also, qualitative expression of solubility. Okay, if a solute is added in the solvent, for example, if sugar is added to a solvent, like water, will it get dissolved? Yes, you can see, you can observe it and tell. That is meant by qualitative expression. When a solute is added to a solvent, by observing it, we can tell that. Is it solubilized or non-solubilized? But what about quantitative expression? Quantitative expression, it is based on the concentration or number of solute. And it is done in two ways. Okay, the terms. Okay, quantitatively solubility is expressed based on this. Okay, this tabular column is very important. Okay, and these terms. Okay, descriptive terms, very soluble, freely soluble. And look at the second column. Parts of solvent needed per part of solute. To dissolve one part of the solute, how much amount of solvent is required? Okay, that is given in second column. And third column, the solubility range. So look at the first term, very soluble. Okay, in the second column, how much it is given, how much parts is given for the term very soluble, less than one part. From the term itself, it's clear, very soluble. That's so, in order to dissolve that solute, only less than one part of solvent is required. Okay, next term, freely soluble. How much? From 1 to 10 parts. See, the number is increasing. For very soluble, only less than one part is required. For freely soluble, from 1 to 10 part is required. Okay. And about soluble, from 10 to 30 parts. See, in the descriptive term, the solubility is decreasing. So, in the second column, the parts of solvent to dissolve one part of the solute is increasing. For sparingly soluble, to dissolve one part of the solute, 30 to 100 part of solvent is required. For slightly soluble, 100 to 1000 parts. Similarly, see the last term, practically insoluble. Means the solute is very insoluble in that solvent. In order to dissolve that solute, more than 10,000 parts of solvent is required. Okay. So, clear? Clear. So, clear about those terms, saturated, unsaturated, and this tabular column is very important. And the concentration of solute is also expressed quantitatively based on molality, parts per million, also volume by mass percentage. Okay, so are you clear? Any doubts? Okay, thank you.